This video is about squares, perfect squares in fact. And perfect squares are when the same number is being multiplied by itself. So for example, 1 times 1 is 1 squared, and that equals 1. And 2 times 2 is 2 squared, which equals 4. And 3 times 3 is 3 squared, which equals 9, and so forth. We're going to write down the first 10, so follow along. 4 times 4 is 4 squared, and that equals 16. 5 times 5, which is 5 squared, equals 25. I'm going to write the rest of them over here. 6 times 6, which is 6 squared, is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. So there's the first 10 perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And of course they go on forever and ever and ever, because you can multiply any two numbers by themselves and get a number. So as many digits as you can think of are perfect squares. What you should know is probably 1 through 15. So we're going to keep going, and let's do 11, which is 121. And then 12s make 144. 13 times 13 is 169. 14 times 14 is 216. Let's check and make sure. We got 14 times 14. Oh, 196. I was wrong. Seemed like a little bit too high. And then 15 times 15 is 225. Alright. I think 16 times 16 might be what I was thinking of. But here are the first 15, and this is something that you're just going to have to memorize. What your goal is to be able to recognize these numbers as perfect squares. So if you see the number 16, the first thing you think of is, oh, that's 4 squared. And if you see 81, you think, oh, that's 9 squared, because it's going to help you later in higher level mathematics, even in this year. So one of your assignments is to figure out what a perfect square is. For example, when we talk about perfect squares, they go hand in hand with square roots. So the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And the reason why is because 3 times 3 is 9, 2 times 2 is 4, and so forth. So all of these numbers, this is why it's important for you to recognize them. So as soon as you see them, you know that it's a perfect square. So we'll do, keep hitting that thing. The square root of 36, the square root of 49, 64, 81, and 100. And then we'll go ahead and do 121, 144, 169, 196, and 225. And so now we have the square roots. So the way you say this out loud is the square root of 49 is 7. The square root of 121 is 11. Now, the reason why square roots are what they are is because, let's do 36. 36 is 6 because 6 times 6, which is 6 squared, gives me 36. So all of these go hand in hand. The square root is 6 because 6 times 6 is 36. And so you have to know one to know the other. But the interesting thing is the square root of 36 could be negative 6 as well. Because watch, negative 6 times negative 6 gives me 36 too. So actually we have two possible answers. We have positive 6 and we have negative 6. And that's true with every square root you could ever imagine. All of these are going to have positive and negative answers. So there actually are two answers to each of these. So we're going to go back through, and the square root of 1 is positive or negative 1. The square root of 4 is positive or negative 2. It could go either way, and so forth. So we're going to put positive and negative symbols in front of each number, which means it could be either one. There's two possible answers for all of these. We're not sure which one it is, so we're going to write both answers. And the shorthand is that you put a plus and minus in front of it. So for example, positive and negative 15, that means the answer could be 15, or the answer could be negative 15. So there's two possible answers. Okay. I think that's enough. Let's go ahead and label this. This is square roots. So these are square roots, and then these are perfect squares. And like I said, they go hand in hand.